Hello, in this video we're going to talk about something called a standard score. Okay, better known to us, and what we'll be using it for is how to calculate a z-score. Z-scores are used if we want to compare data from different samples. To compare data, I'll put this up here quick, from different samples. Okay, so what we do is we do a conversion so that all of our data values are on kind of like a level playing field. We want to convert things into a z-score such that when that happens, we have a mean and a standard deviation, 0 and 1. Okay, so it's like you're taking your number line and you're saying, okay, let's do a true number line. Let's make the mean be 0. If we count by ones, okay, and notice I'm not putting on here the S's like I had before, like 1 deviation, 2 deviations, 3. The actual standard deviation size is 1, so we're actually doing like a true number line. Okay, so then if we convert everything into a standardized score, we can place it on kind of an equal playing field. We can place it all on the standard number line and then do comparisons. There's two formulas, and you're welcome to add to your formula sheet. One is if we have sample data. The other is if we have population data. So the first one here, you're using X bar and S. That would be for sample data. The second, using mu and sigma, is if you have population data. Okay, and both will give you a z-score. Either way you look at it, when you calculate z, you're doing your score, whatever it is, minus the mean, and you're going to divide by the standard deviation. Okay, it's just like I said, one is for sample, the other is for a population. So we change the notation. Okay, also, if you think about it, a z-score is the number of standard deviations. The variable is from the mean. So how far are you from 0? Okay. All right, let's take a look at one of these. So we'll go down here to the example. So I'm down here to the example. A student scored 65 on a calculus test, having a mean of 50 and a standard deviation of 10. The student scored 30 on a history test, having a mean of 65 and a standard deviation of 5. Compare the relative position on the two tests. Okay, wonderful. So for calculus, we'll start out here, a z-score. All right, so we need, what was the student score? Okay, well, student scored 65 minus, okay, the mean on that test was 50, okay, and then you're going to divide by that standard deviation, which is 10. Okay, so that should come out here 15 over 10. So we're saying the calculus z-score is 1.5. Okay, so in other words, on the calc test, the person scored 1.5 standard deviations above average. In fact, if I use that up here at the top, let's say right here, that's the calculus test, 1.5 deviations above average. All right, let's keep going. Next up is history. It says the student scored a 30 on a history test, having a mean of 65 and a standard deviation of 5. Okay, so the z on history, the score for the student is 30, minus 65 for the mean, divided by a standard deviation of 5. So this time, we have negative 35 over 5. Oh dear. 7 z is negative 7. All right, I chuckle because I didn't make my number line big enough up here to deal with that. So we would go clear down here to negative 7 deviations below average. So I think that person's probably history and history. Oh, a little bit of joke there. All right, so what's our conclusion here? Well, the calculus z is greater than the history z. So the person did better on the calculus test because the position is higher. Okay, we're above average on calc. We're way below average in history. Okay. Something to notice here, and I put this in just in case. If a z is positive, the score is above the mean. If the z is negative, the score is below the mean. So it is absolutely okay to have a positive and a negative z-score. It's just above average or below average. Okay? All right, let's keep going. Got another example here. Adult males have heights with a mean of 69 inches and a standard deviation of 2.8 inches. Find the z-scores corresponding to the following. Basketball player Muggsy Bogues, who is 5 feet 3 inches tall. And I selected him. Some of you may not know him, but Muggsy's the smallest male to play in the NBA. So I thought maybe you sports fans might find that interesting. Okay, so let's start out here with, 5 feet 3 inches. So that's going to give us 63 inches for Muggsy's height. So when we convert to a z-score, we'll say 63 minus 69 divided by 2.8. So Muggsy is negative 2.14. That's his z. So he's 2.14 standard deviations below average for the height of a male. And if he's the smallest to play in the NBA, that seems to make sense to me. All right, next up, Evan Turner. I thought maybe you Buckeye fans might know Evan Turner. He played some really good basketball back in the day for your Buckeyes. Okay, so for Evan, he's 6 feet 7, which is 79 inches tall. So his z-score, we would do 79 minus 69, divide by 2.8. And let's see here, Evan is a 3.57 for his z-score. So he's almost 4 deviations above average. So that would say he's pretty tall. Okay. So again, we're just using the z right now to compare two different people or data sets. And we're putting them on a level playing field, the typical number line up here, to compare their relative positions. Okay. All right, second example. The number of hours that college freshmen spend studying each week have a mean of 7.06 hours and a standard deviation of 5.32. Find the z-score for a freshman who studies 20 hours per week. All right, so this person's z, we're going to have their time, 20 hours, minus the mean. The mean's right here, 7.06. And we'll divide by 5.32. That's the standard deviation that we're given. We'll say this person's z-score, 2.43. So that means they are 2.43 standard deviations above the mean. They performed above average. Okay, so then the last couple examples, again, just some basic practice here. If you want to stop the video and try and fill these in on your guided notes by yourself and then come back and check, that would be fabulous. Otherwise, I'm going to just continue here, okay? So it says, of these three, which of the following corresponds to the highest relative position? So which one is the furthest to the right on our number line? All right, so first one, we have a score of 37. So the z is going to be 37 minus the mean, 28, divide by the standard deviation. Okay, on the calculator, I get 1.50. Second one, they scored 398. Mean 312, divide by standard deviation of 56, 1.54. And then lastly, the z, 4.10 minus 2.75 is the mean, divide by 0.92. This one is 1.47. So the one that is furthest to the right or above average is the 1.54. Okay, so the best score on this one is the 398. It has the highest relative position. All right, last up. And again, if you want to stop the video and then proceed, okay, go for it. So this time it says, again, which one has highest relative score? So we have a z value for A, 2.7, minus 3.2 is your mean, divided by 1.1. that's going to drop us in at a negative 0.45. So we are below average. Okay, second one. Score of 27 minus 35 over 12. Divide that, we're at negative 0.67. And again, we are below average. Okay, and the last one, we have a z of 850, or sorry, will be 850 minus 921 over 687, which will give us a z-score at, let's see here, negative, sorry, lost my place on my notes. It looks like negative 0.103 on there. Okay, so then it wants to know which one has highest relative position. 687. I'm just checking the arithmetic here real quick. I don't want to leave you out in the snowstorm without the right answer. That wouldn't be very nice, would it? But we might if I can't find a calculator. Oh, here we go. 850 minus, wish we were in class. You could just say, hey, it's all right. Don't worry about it. Yeah, negative 0.10. Okay. So then it says, which one has the highest relative position? Well, it looks like this one right here, huh? Because it is closest to 0. So we're going to take this one. So we will say, sorry about that. Had a little question mark on my notes. The score of 850 has highest relative position. Okay, so again, if you take a minute here at the end, go back up here to the top. You want to, where I've just kind of made a mess, add this formula, both of them, to your handy dandy formula sheet. So if you have to calculate z-scores, you'll be good to go. And again, it's just evaluating positions. And always remember that when you're doing standard scores, the mean is 0 and the standard deviation is 1. All for now. Signing off. Have a great day.